सपोज हमें क्वेश्चन में दिया हुआ है, ओपैम्प का क्वेश्चन है, V नॉट इज इक्वल टू -6V1 -4V2 प्लस 9V3। तो सबसे पहले तो हमें किसकी वैल्यू निकालनी है, R1, R2 और R3 की। सिंपल, उसका एक ही फंडा है। कैसे? जैसे तुम्हारे पास स्टैंडर्ड इक्वेशन क्या होती है, V नॉट इज इक्वल टू माइनस RF बाई R1 V1 माइनस RF बाई R2 V2 माइनस RF बाई R3 V3। ठीक है, इसको इससे कंपेयर करेंगे तो हमारे पास, हमें यहाँ पे एज्यूम करना है, लेट अस कंसिडर RF वुड बी इक्वल टू 10 किलो ओम, राइट। तो यहाँ पे RF की वैल्यू हमने क्या कर ली, 10 कर ली। तो 10 बाई R1 इज इक्वल टू 6। तो यहाँ से हमारे पास R1 की क्या वैल्यू आ जाएगी, 6/10 नहीं 10/6 आ जाएगी। सिमिलरली हमारे पास R2 की क्या वैल्यू आ जाएगी, 10/4। और सिमिलरली R3 की हमारे पास क्या वैल्यू आ जाएगी, 10/9, राइट। तो जो भी तुम्हारे पास ये वैल्यूज आ रही हैं, इसको तुम्हें R1, R2, R3 तो हर बार निकालना पड़ेगा, वो हमेशा कैसे आएंगी, 10/6, 10/4 और 10/9 करके। ओके, उसको 10 से डिवाइड कर देना। अब दूसरी चीज हमें सर्किट ड्रॉ करना है। फिर से मैं लिख रही हूँ -6V1 -4V2 and this one is plus 9V3, right? Now as you can see that V1 and V2 and V3, like there are three inputs, so ideally what should be the output, V naught is equal to -6V1 -4V2 and it should be -9V3, right? अगर तीनों ही नेगेटिव है सपोज, तो व्हाट वी कैन डू, पॉजिटिव टर्मिनल ग्राउंडेड और नेगेटिव पे मैंने तीनों को कनेक्ट कर दिया, राइट। ये हो जाता V1, V2 और V3, राइट। आउटपुट इज V नॉट, आउटपुट इज V नॉट एंड द फीडबैक रेजिस्टेंस इज RF, राइट। बट अब हमारे पास द प्रॉब्लम इज कि हमारे पास ये नेगेटिव नहीं है, V3 is not negative. Instead of negative, we'll have positive sign, right? Correct. So if we want to change the sign of anything, we can use for that inverting amplifier. हम कौन सा amplifier use कर सकते हैं, inverting, because as you know inverting output is V naught is equal to minus of RF by R1. So inverting से we can change the sign. So we want to change the sign of V1, V2 or V3. Tell me. V3. तो V3 के आगे if I'll put an inverting terminal, inverting amplifier, this is again RF, we know the value of R1, this is R3, so this is V3, right. Now see, we'll have now positive V3, then in the output we'll get it as negative V3, right. So this one would be positive, this one is negative. Generally the output will be how much, like -V1 -V2 -V3. But now as you can see that V3 sign is changed, so it would be positive V3, right. So iska ye banega. In this we have used two amplifier. One is the summing amplifier, this one is the summing amplifier, and this one is the inverting amplifier. So that depends what they have given in the equation. Suppose we'll have V naught is equal to 3V1 minus 6V2 plus 9V3 and you have to draw the circuit by using OPAMP. सबसे पहले तो as I told you, how can we get R1, R2 and R3? If they have given RF is 10 kilo ohm, then it's fine. If they don't give, then we have to assume it, right? So R1 is how much? I told you 10/3. R2 is how much? 10/6. And R3 is how much? 10/9. Simple, you can do it directly. Okay? Clear? And next thing, in this you need to use two op-amps. Okay? This is the condition they have given in your question paper, that you have to use two op-amps. So all the two op-amps will take it as summing amplifier, right. Summing amplifier is positive terminal is grounded again the positive terminal is grounded. With the negative terminal we'll connect the voltage. Clear? Now tell me which voltage is positive, V1, V2, V3. Tell me. V1 and V3 is positive, so I am connecting the positive voltage, that is V1 here and V3. This one is R1, this one is R3, and this one is the feedback resist. Okay, clear? So here, यहाँ पे बताओ, like what will get the output over here? Sanav, tell me how much will we get the output over here? Minus V1 minus connect. Correct. So I'll connect this minus V1 minus V3 as one of the input. What is left? V2. So I'll connect V2 also over here. Right? So now can you tell me the output for this one? As you know, for the summing amplifier standard is like minus V1 plus V2 plus V3. Right? So one of the input is V2 and another of the input is minus V1 minus V3. So basically we need to add it and then bracket के बाहर minus sign, right? So that one minus V1 minus V3 is one of the input. Add it with the next input, that is plus V2, right? If I'll solve it further, minus का तो ये V1 plus V3 and minus V2, that is what we want exactly. Our circuit, I'll tell you. See, one of the thing is CMRR, that is common mode rejection ratio. So define इसकी जरूर करके जाना, because they generally ask you what is the definition of CMRR. It's a common mode rejection ratio. Basically it's the ability of the op-amp that how much they have reject the noise. So there is a proper definition of CMRR, and for that we'll have formula also. CMRR is equal to AD by AC. What is AD? AD is the differential gain. A represents it by gain and AC is the common mode. Okay, and if we want to convert it, like calculate CMRR in decibels, this is gain by gain, so it's unitless. But if they ask you to convert to calculate CMRR in decibels only, so for that we'll have formula 20 log base 10 AD by, right? So now the thing is, how can we get AD and AC? So for that we'll have formula. What was the formula? P naught is equal to AD plus AC. PD is the difference in the two voltage, so it would be V1 minus V2, and V is the common mode voltage, so it would be V1 plus V2 by 2. Okay? These are all the formulas for the common mode rejection ratio. So one of the question will definitely come, maybe from the MCQ type or maybe for 2 or 3. So ये वाला question भी 100% आएगा. This type of question also you will get 100%. And another category of question is like, as I told you, the different types of OPAMP. Remember what are the different types of OPAMP? You need to learn the derivation and you need to learn the output for that. Like one of the OPAMP is inverting OPAMP, another OPAMP is non-inverting OPAMP, another OPAMP is summing OPAMP, another OPAMP is differential OPAMP. Then we'll have in OPAMP as a integrator. Then we'll have OPAMP as a differential, right? And one more thing, we'll have voltage follower. In the voltage follower we don't use any resistance, and this output would be equal to output voltage, right? See what is the output? That is in your notes only. Okay, we haven't done. Okay, I'll tell you. This is for inverting op-amp. You can take the screenshot. Then this is for non-inverting op-amp. You can take the screenshot. Derivation I told you earlier. Remember, like now we don't have enough time to the derivation. This is the diagram and this is the formula. Now, hmm, for voltage, yeah, I'm telling you for that one also. Voltage follower, summing amplifier, difference amplifier की voltage ये output voltage थी. This one is integrator and this one is the difference. The screen of that. In integrator, we'll use capacitor as a feedback, but in differentiator, we'll use capacitor as a input. So the formula for the integrator is minus 1 by RC 0 to T, like its integration form, and it's in the differentiation, right? In this case, they ask you to calculate IZ minimum. So first thing I told you, whenever they'll give you minimum and maximum, we have to use the second condition. So every time we have to use these formulas, right? So in this they ask you to calculate IZ. So first see this question and see where the IZ they have given. IZ is given over here, right? So back to this, that is 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 equal to IZ plus IL. So IZ is equal to IS minus IL, correct? So if they ask you IZ minimum, then in that case we'll take the voltage also minimum, 80 volt, and then we'll do all the calculation. If we want to calculate IZ maximum, then in that case we'll take 120 volt, the maximum, simple. Then we'll do all the calculation. So now let us, for the while being, we need to calculate IZ. So we'll take how much voltage? 80, right? Now tell me the further steps. PL is equal to IL into RL. PL is 50, so 50 divided by 10, it's 1000. So current would be in milliampere. So IL will get it as 5 milliampere, right? IL we got it 5 milliampere. Now we need IS. How can we get IS? IS is 80 minus 50 divided by 5 kilo. That's 6 milliampere. So 6 milliampere minus 5 milliampere will get it as 1 milliampere, right? So we get IZ minimum. Now in the another case, if we'll use 120 volt, IZ maximum. Now tell me, is this easy or not? The harder one also. This is your paper question. All your previous year question. Now in this case, there is not the condition of minimum and maximum, right? So in this they have given the supply voltage VIN. This time they have denoted by VIN. So you have to understood by your own. VIN is the input voltage, VS is the supply voltage, all these things are same. And RS is they have given 220 ohm, that they have given as 10 volt, and RL is equal to 50, and this given that maximum is equal to 400 milliwatt, right? So in this case, what you need to calculate, you need to calculate determine L, IL, IZ, IR, all this thing. Again, this is from your paper. Now see, now they have denoted by IR, but it is equal to IS. So don't get confused with the notation. Your mind. PL, IL, IZ is same, so what should be IR? Obviously, it's this one. So IR bolo ya IS bolo, one and the same. Now do it. Like in this, you are getting confused in the notation. VS should be me supply volt, right? This one is the supply voltage, because this is the voltage only now which is supplying towards it. V in, sometimes they can also give you the V in, that is in means input voltage. So what is the input voltage? Input voltage is this one only, right? Because this is the voltage which we are providing. Next one is Vz. Now tell me what is Vz. Z stands for zener. So it's a zener voltage. Okay. And then another is VL. VL. Here L stands for load voltage. Which one is the load voltage? This one always. Okay. This is across the load resistance. So voltage across load resistance would be load, or we can say V naught. No, Vs is the supply voltage. This one is the load voltage. Like suppose this is the Vs and V in, they are same. Sometimes they can give you V naught. Naught means O, that is output voltage. Output voltage will always measured across the load. So VL and V naught are same. L is equal to V naught and Vs is equal to, okay. And they have given Rs also. Rs is what? This one, supply resistance, right? Rs is supply resistance. So I am drawing the diagram. This one is Vs or in. This one is Rs. This one is Vz. This one is RL. This one is L. Right? What is left? This one is the current, supply current. The current across zener would be zener current. Current across load would be IL, load current. Write down this one also. Is is the supply current, Iz is the zener current, and IL is the load current. Okay. We'll have formula for VL is Vs into RL by Rs plus RL. Right? Told you this one is the formula for the condition checking. So Vs is how much? 20 only, and RL is how much? 50 multiplied by 50 plus 20. So if we solve it, then we'll get 3.7 volt. Now tell me which condition satisfies. VL we got it as 3.7 volt, and VZ we got it as, if they have given VZ, that is 10 volt. So VZ is greater or VL is greater? Z is greater. So which condition satisfy? First one or the second one? First one, right? So now we'll use all the formulas of the condition of first case. Understood? Now we got VL, that we got it as 3.7, correct? Now calculate IL. See the formulas from here and calculate IL. Okay, so we'll get IL as this one as 74 milliampere, right? Is is equal to IL, and Is is how much? Like Vs 20 by 220 plus 50. Now calculate Iz. Okay. In this case, Iz is equal to 0 and IR is equal to IL, that is 74 milliamp. Now tell me, this one would be difficult or easy? But Iz is Is minus IL. So minimum hai, we need to take 9 volt. Right. Now tell me the further steps. See, we just substitute the formula Vs minus VL by Rs from this, and IL is equal to VL by RL. So इसमें you can write down this thing like VL is equal to IL into RL, right? तो एक और formula यहाँ पे add कर लो. So see how simple it is. Now let's see. hmm? VL is equal to IL into RL. Basically, it's from the Ohm's law, but still you can write it down. Now see, I solved this question a single step, right? अब now see your solution जो तुम्हें मतलब PDF में दिया हुआ है उसमें बहुत they have done in a very lengthy way. So rectifier, as I told you, one of the question will definitely come 100% from the rectifier. Like I told you, zener से एक question आएगा 100% and rectifier से maybe more than one, but one तो आएगा ही आएगा, right? So remember how many are the different categories of the rectifier we have? One is the half wave rectifier and another one is the full wave rectifier, right? In the half wave rectifier we'll use only single diode. Full wave rectifier is further divided into two categories. One is the center tap and another one is the bridge type, right? Up now you need to remember all the formulas for the rectifier. Did you? In this case, this is the half wave rectifier, this is center tap and this is bridge type. So they can ask you to draw the circuit diagram and the waveform. Okay. So this one is the circuit diagram. Waveform for the half wave rectifier is this one, and the for the full wave, like it is like this. Okay. Now half wave rectifier, it will form ripples. Okay. Ripples. So these are the formulas for the half wave rectifier and full wave rectifier. Just take a screenshot because you need to remember this formula. These formulas are also not mentioned in your handbook as well. इसका screenshot ले लो. This one also. This one. Whenever they which rectifier they are asking fire, and whenever they'll give the ratio of the transformer, step down transformer, then always in that case calculate the second, right? Obviously they'll give you the primary voltage and we need to calculate the second. For that you have formula that you must, that is N2 by N1 equal to by V1, right? N2 equal to V by V1. Now see, this is N1, N2 and this one is the primary voltage. Get all the value. N2 is 1, 4. V2 calculate. 1 is 2. Tell me V much. That would be 20 divided by, correct? Got from, that is how much? By 4. 55, right? Now one more thing, you remember that we always use RMS value for the calculation or the maximum calculation. We always use for the RMS. Always RMS. And there is relation RMS. What is that is VRMS by, right? Got this voltage as a max, but we do want max. The RMS 55 divided by, right? Okay. Now see, they didn't, that is this RMS They didn't get RMS term. Okay, sorry. This is RMS. Now suppose if we want the maximum volt, that would be 5 equal to V max by, so V much 5. Understood? Now we need to calculate DC output, right? Case of bridge rectifier, that is IDC into, right, that V equal to, like, for that would be pi pi, right? But for that we need max, we have already calculated, so we just need to substitute the value. Substitute the value, final answer for that, for VD. For this calculate, right, for I according to equal to V by R, I would be equal to, if I is max divided by RL. I've calculated, that is 55 divided by RL. They didn't give the diode resistance. If they had the diode resistance, consider, but in this case they have given the load resistance is 1 kilo. RL is 1000. Now we got I max, substitute, have RL, the, right, or we can directly max, then we'll get, so we have 3 formulas, right? Five 19 watt. Now see what they have asked. They have asked PIV. PIV means first voltage, and P is the Vs that we already calculate, right? Again for the second side. Next is output. Output always twice of supply frequency. Supply frequency. Write down this formula in that output frequency equal to twice of supply frequency. Peak burst is, they have 500, diode resistance 50, diode resistance RF 50. Now they don't the direct. We know the standard T. From here, right, we'll get 5. From here, if we need, till now, that is 6. Now back to the question, they ask you current, the maximum, and the formula for the maximum current practice what? Divided by RL plus RF is given, divided by RL is 500, RF is, we can solve it, then we'll get the maximum current. Yes or higher, got it from high average IDC, the answer for A. Now next, let F percent tap rectifier divided by plus R by R multiply have RF, solve it and binary पर आता है. Like they can ask you by using one's complement and by using complement. So I am giving the same example by using ones and have 1 1 1 0 1 1 1 1, and we have to perform it by using ones complement, right? The step number 1, the number which we need subtracted have to take ones complement by using complement. The number which subtracted take ones complement. So ones complement of the 1, correct? Okay. Now if we'll do by 2's complement, take 2's complement number of the number which we subtracted. So take first complement 1 0 and 2's complement लेते हैं by adding 1 to it. That would be 1 1. बोलो कोई doubt? The first step. Yeah, the number which we subtracted, अगर हमें ones complement करना है then take ones complement, अगर हमें two's complement करना है तो take complement of that particular number. Clear? Tell me. Now the second step, whatever we got it, the number we have to add number से हमें करना है. So add this number, that 1 0. Similarly इसमें have to add this, right? This same step है, right? Add it, that will get it 0 plus 1, 1 plus 1 is 1 would carry, so 1 plus 1, then 1, then correct. Now if we'll add it here, then 1 plus 1 is 0, 1 carry, 1 plus 1 is 1, 1 carry again, then 1 plus 0 is 1, then 1, right? Now tell me, any doubt up to here? Like first step is also same for both the case, is also for both the case. Understood? Okay. Now you can see that in this the MS got it as 0. That would term. Then in that case have to take one's complement of the result. What is the one's complement of that? That 1, right? And it's MS, so the answer would be negative. This is our fun. Now see for the second complement. Now here also we got it 0, huh? Because like see, if the MS term is, if the MS 1, the term is positive. Is M the most significant 0 is the this is MSB in bit, LSB. If MS the answer is 1, then the positive. Okay, understood? Now in this case also we got it as 0 as the MSB. Now we have to take 2's complement of the result, right? The MSB. Now we have to take 2 complement. यहाँ पे we have to do it by 1's complement. That's why we have taken 1's complement. We have to do it by here by 2's complement. We have to take the 2's complement of the result. So what would be the 2's complement? First we need to take 1's complement 1, right? Sorry, it carry only. So add 1, that would be 1 plus 1 is 0, 1 carry, and that will be, the answer is 1's complement. The 1's complement, right? Right? Now see 4 digits, 4 digits. Here, but they have given here digits. By own can assume it as 0, right? Is there any change in the value? If I add 0 by my own over here, 1's complement, correct? Now we have to add the number 1, 1, right? Add it to 1 plus the carry, correct? I have done it for the 1's complement. It's same for the 2's complement. By using first we need that case add, right? So plus 1 like so we add 1 over here. So plus 1, yeah, 1, 1, got it for the complement, right? Here we are getting here we are getting is 1, right? Remember in the last case we have to 1's complement further. Now in this getting 1, now what we need to add 1, okay? Whenever we add 1 in the point form, always add after that. Clear? It would be 0.1, 1, 1. Similarly, also we add 1 complement final answer. So we got, so here if here in this carry, the final answer again got the same 1 point. Okay, understood? Like for boolean data, plus a is a into 1 plus something 1 only, a plus bar 1 a in bar are the a